Quiz 10. Use scientific notation to express the number 650 to one significant digit. So 650. So we want to go to one significant digit. This number ends exactly in a 5. And so we look at the number 6. Notice that it's even. So therefore we have to round down. And so it would be a 600. And we have to express this to scientific notation. So this would be 600 expressed to one significant digit. So 6 times 10 to the 2. 6 times 10 to the 2. That would be the answer. Use scientific notation to express 650 to two significant digits. Okay, 650 to two significant digits. That's going to be 6.50. No, excuse me, 6.5 times 10 to the 2. 6.5 times 10 to the 2. Two significant digits using scientific notation. Use scientific notation to express the number 650 to three significant digits. So that's going to be 6.50 times 10 to the 2. 6.50 times 10 to the 2. Use scientific notation to express 650 to four significant digits. That's going to be 6.500 times 10 to the 2. That's four significant digits. Use scientific notation to express the number 635.5 to three significant digits. Okay, three significant digits. So these three right there. 635.5. The number ends exactly in a 5. So I look at this. It's odd, so it rounds up. So it's going to be 636. So 6.36 times 10 to the 2. Use scientific notation to express this number 0.002945 to three significant digits. 1, 2, 3 to 294. This digit has a 5, but it's followed by other digits, so we're going to round up. So it would be 1, 2, 3, 2.95 times 10 to the negative 3. 2.95 times 10 to the negative 3. Now we have to round this to three significant digits. So when we round this to three significant digits, 8.500, so therefore it's going to be 8.50, and it's already less than 10 times 10 to the 0. So 8.50 times 10 to the 0. That would be according to scientific notation. And so use scientific notation to express this number to three significant digits. 403, and then we have a 5 here. Three significant digits. So notice the number ends exactly in a 5. We want to go to these three digits. And so since we have to go to this 5, we look at this digit here. This digit is a 3, so it rounds up to 0.404. So using scientific notation, we move that decimal point back. So it's 4.04 times 10 to the negative 1. 4.04 times 10 to the negative 1. See how that works? This rounds up to a 4, so we're going to have 0.404. And then we move that decimal point on over, and 4.04 times 10 to the negative 1. 4.04 times 10 to the negative 1. Use scientific notation to express the number to three significant digits. So three significant digits, that's going to be this one, and this one, and this one. This number ends exactly in a 5. So I look at this 2. This 2 is even, so it rounds down. So I'm going to have 99.2. 99.2. So now when I round to three significant digits using scientific notation, I'm going to get 9.92 times 10 to the 1. Right there. Now when we calculate these, what we have to do is we have to make sure that they all have the same power of 10 when we add and subtract. They have to have the same power of 10. So let's just go to the 0. So if we go to the 0, then this is going to be 3, 8, 5, 3. So I moved it over 1. I move it over 2. Move it over 3 places times 10 to the 0. Now do the next one. I move it over to the 2 places. So it's going to be 42,603. So 42,603 times 10 to the 0. And then this last one is going to be 1004, 1004, and that's times 10 to the 0. Okay, so now they are all in the correct power of 10, in the same power of 10. So, and we're adding them all. So we're going to be able to just go through and write out our mathematical answer first. 709. See, 5, 6, 7, 8, 8 and 4 is 12. And so then 4, we have the 4 there. And so, and times 10 to the 0. So this is what we would do. And then we have, this is our mathematical answer. And so now we have to look at significant digits. Notice that this number has only 4 significant digits. 1, 2, 3, 4. These other 2 are not significant. They're just placeholders. And so we do not have digits there. So that means we have to be able to express our number not to the ones or the tens, but to the hundreds. So we have to be able to express our number right to there, to the hundreds place. This is times 10 to the 0. We want to make sure that we use correct scientific notation. So times 10 to the 1, 2, 3, 4, 5. So we're going to get 4.289 times 10 to the 5th. 4.289 times 10 to the 5th. That's going to be our answer. Do another one. And so here we have something to the 6th, 7th, and 8th power, and we're going to add and subtract. So let's just put everything to the 6th power. 29.505, and this is times 10 to the 6th. And then we have 4.25 to the 7th, so that's going to be 42.5 times 10 to the 6th. Times 10 to the 6th. And then we have to the 8th power, so 1, 2. So it's going to be 200.01. So 200.01 times 10 to the 6th. Okay, so this is our problem. They're all to the same power, and we're going to add this one, and we're going to subtract this one. So I get out my trusty calculator, 29.505, and I'm going to add to that 42.5, and then subtract 200.01, and I get negative 128.005. And then it's times 10 to the 6th. Okay, so this is my answer. Notice that they do not have to the thousands or to the hundreds, but they do have to the tenths place. So that means my answer has to be to the tenths. So I have to go to 1, 2, 3, 4 places is what I'm going to have. And so times 10 to the 6th, times 10 to the 7th, times 10 to the 8th, negative 1.2. So I should get negative 1.280 times 10 to the 8th. Negative 1.280 times 10 to the 8th. Okay, so now I'm going to do it again. Practice some more. So I have these all go to the -3, -4, and -2. So let's see. Why don't we just make them all to why don't we make them all to the -4? Why not? So we have if we go to the -4, we're going to have 6.79 times 10 to the -4. And then we're going to have, and it doesn't matter. I mean, you can put them to any of the powers. I mean, I'm just picking one. I mean, we could have went to the -3 if you like. So 6.79 times 10 to the -4. And we have 2.042. 042 times 10 to the -4. And then we have 3942 times 10 to the -4. And so we have all of these. I'll put that under there. And we want to add them all. So we have a 2, and 9 and 4 is 13, and 8, decimal point, 6, 7, 8, 9, 10, and a 5, and a 3, and a 9. Okay, so that's our answer. Oh, times 10 to the -4. And so times 10 to the -4. Now notice that they do not have to the thousandths, or to the hundredths, or to the tenths. So we have to go to the ones place. So we have to go right to there. And this is to the -4, -3, -2, -1. So my answer is going to be 3.95. Now this 0 here, we look at this digit, it's greater than 5, so we round up. 3.951 times 10 to the -1. 3.951 to the -1. So now we go to the -7, -9, and -6. So you can go to any one of these that you wanted. So let's go to the, let's just do the -7. 1.68 times 10 to the -7. And so we have -9, -8, -7. That's going to be a 2.445 times 10 to the -7. And then I have, I'm going to have, bring this decimal point over, 0.025, 0.025 times 10 to the -7. And so we do this, and then we add this one and subtract that one. Okay, so our power is going to be to the -7. Get out the old trusty calculator. 1.68 plus 2.445 and minus 0.025. And I get 4.1. I get 4.1. That's it. So 4.1, I'll just go ahead and put these zeros in. 4.100, because we go all the way to the thousandths here. So now when I want to talk about the correct way to represent this number, notice that they do not all have to the thousandths place, but they do all have to the hundredths. So I have to express this number to the hundredths. So my answer is going to be 4.10 times 10 to the -7. 4.10 to the -7. That's going to be the answer. I hope you did well, and if you have any questions at all, please don't hesitate to ask. Enjoy your day.